This lesson takes our knowledge of SOHCAHTOA and moves it on to using it for solving problems that involve two triangles. So just a rule of thumb here, when we're doing something with two triangles, nothing else has changed. All the information we learned before still holds true. One of the things you have to remember, and I'll show it right off the bat, is that your calculator must be in degree mode, so go make sure and check that. But one of the big hints, or a good place to start when you're doing two triangles, is always try to find, or a good rule of thumb is try to find what they're sharing. That would be something that would help unlock this question. So in this first example, it's saying solve for x and y, and we should be able to see there's two triangles. There's this triangle, that's a right triangle, and there's also this triangle. And it is asking us to find x and y. So where should we start? Probably with the side they share, which is this side x. That would probably help us find the information that we need. So let's start there. If I'm going to find this side x, I'm going to have to use this triangle here. The reason I'm going to use this triangle is because I have an angle, I have a side, and then they only have the one unknown, which is x. So if I look at this diagram, if the 40 degrees is my reference angle, this is my adjacent side, and x, since it's across from the right angle, x is my hypotenuse. So again, what I would do, or what I would suggest to do, is rip out that thing we're looking for, and it might not be exactly the same. Here's my right angle, here's 6.4 meters, here's the 40-degree angle, and this is the side x. Sometimes getting it away from the rest of the information will just help you sort things through. So if I was looking with this being adjacent and this side being hypotenuse, that's cosine. So we're going to say the cosine of 40 degrees, adjacent over hypotenuse, the cosine of 40 degrees, the adjacent side is 6.4, and my hypotenuse is x. Now this is where we started to say, let's put this over 1, and we're going to cross multiply. So x would equal the line that has two numbers on it, so 6.4 multiplied by the 1, divided by cos of 40. So again, your knowledge of cross multiplying here is going to be key. So I'll show you over on the calculator what this would calculate as. 6.4 multiplied by the cosine, it's 6.4 times 1, which is still 6.4, divided by the cosine of 40 degrees. So if we did this, this hypotenuse, and we'll round to one decimal place, is approximately 8.4 meters. Now, it's a good idea just to do a reasonable check here to say, well, if the hypotenuse is 8.4, it better be longer than the other side, which is 6.4, because we do know that the hypotenuse is the longest side in a triangle. So at least I know my answer is reasonable. So I found the x. So I'm going to go back to my diagram. I'm going to erase all my scribbles, and I'm going to say, okay, I'm looking now at this triangle with the 68, and my x, which I just found out to be 8.4. And I'm now trying to find y. So again, I'm going to pull this triangle out, kind of how I see it, like this. Here's the 8.4, here's y, and this is 68 degrees. So now when I look at this diagram, if this is my reference angle, 68, this side is now the opposite of 68, and this side is adjacent. So when we look up our little SOHCAHTOA, that's tangent. So we're going to say the tan of 68 degrees is opposite over adjacent. The tan of 68 degrees, now we can put in the values we know, opposite 8.4, my adjacent is y. And now I'm going to have to put this over 1, do some cross multiplication. So again, y is 8.4 multiplied by 1 divided by the tan of 68. And I'm running into the bottom question here, but that's okay. So in the calculator, 8.4 times 1 is 8.4 divided by the tan of 68 and we get roughly 3.4 meters. So the question asked to solve for x and y, and we found them. And it all started with finding the side that they shared, and that helped us solve for y in the second case. So now let's look down here at the flagpole question. We have a flagpole that's supported by two guy wires, and these are my guy wires here. Guy wire is just attached to something to keep it up. So there's one guy wire, there's the other guy wire, and they're saying they're both, let me just erase part of this now so we can read that. They're both attached 4 meters from the base of the flagpole. So here they are. So these things are pinned down right there, away from the flagpole, keeping it straight. The guy wires have angles of elevation of 35 degrees. So this guy is 35 degrees. Holding this up. So there's the 35. And then there's a 45 degree. The one that's higher up is at a 45 degree angle. So we're just trying to understand what the question's saying. What it's asking us now is how much higher up the flagpole is the top guy wire. So it's actually asking us to determine this little distance here, because they're both tied to the flagpole right there. We need to figure that out. So our plan of attack should be to find the height. I'll put it all in blue here now. If I could find this height y, and then go in and find this height x, if I subtracted those two values, I'd be left with this little chunk there. That's the difference between them attached to the guy wire. So again, we're going to take a step back. I'll erase all this stuff we put on there. I'm going to start by finding that longer distance. So I'm going to look at this triangle. Now, one of the assumptions in trig, unless the question says otherwise, you can always assume something stuck into the ground makes a right angle. So I have this large triangle with a 45-degree angle. So again, we're going to take this out. We're going to say here's this, here's 45, and here's 4 meters, and it's asking me to find y. So to do this, we should say, well, here's opposite, here's adjacent. Opposite and adjacent is tangent. So we're going to say the tan of 45 degrees is opposite over adjacent. The tan of 45 degrees, the opposite is my unknown in this case, and that's y, the higher reaching guy wire, and the adjacent is my 4 meters. Put it over 1 and cross multiply. So from the example above, this is a little different. The line or the stick that has two numbers on it is tan 45 and 4. So I'm going to multiply those. 4 times the tan of 45 degrees, and then I'll divide by 1. So over here we can look 4 times the tan of 45 degrees, and we should know that when we divide by 1, nothing will change. And that means right here, that longer guy wire is also 4 meters up. So this height is 4 meters. Now I'm going to go, and I'm going to look at that smaller triangle, which is this one in red. Again, we can assume that the flagpole is at a 90-degree angle. But now we have a 35-degree angle there. So I'll recreate this diagram over here to get it out of the mess of what we see. So we got this. Here's 35 degrees. Here's 4 meters. And it's asking us to find x. So if we look, this is opposite the 35 degrees. This is adjacent. This is another tangent question. So now we'll say the tan of 35 degrees this time is opposite over adjacent. The tan of 35 degrees, the opposite was x, the adjacent is 4. Place the tan of 35 over 1 to make it a fraction, and we cross multiply. So my x would equal 4 multiplied by the tan of 35 degrees divided by 1. And we can do that in our calculator. So 4 multiplied by the tan of 35 degrees, dividing by 1 won't make a difference. So we get this is 2.8 meters. So I've got the x and the y. So what I do know is that this x was 4 meters. Sorry, this y was 4 meters. This x is 2.8 meters. And the question's saying, okay, so what's this chunk here? All we need to do is subtract these two values. So 4 minus 2.8, and you could use your calculator, or we can know that this is 1.2 meters. So these two cables are attached 1.2 meters apart, and there's your final answer. So we had a lot of work to do to find this out. But now the question, the second part of this question, is asking us something entirely different. And I'm just going to separate this work here so we don't get confused. Saying how long is each guy wire? So these guy wires are actually attached, and we just don't know the length of them. We could go and use Pythagoras because we have the x and the y value. I'm going to use trig because it is our trig unit. So all I'm going to do first, I'll look at the small triangle. This small triangle here. If this is 35 and this is 4, now it's asking me, how long is this wire? So I'm basically finding A with the assumption of that 90-degree angle. So now, I'll just extend my page a bit. I could take out that smaller triangle and say if this is 35 and this is a right angle, and they told me this is 4 meters, what's this? Or as the question labels it, A. So if this is my reference angle, this is adjacent, and A, because it's across from the right angle, is my hypotenuse. Adjacent and hypotenuse, that's cosine. So the cosine of 35 degrees is adjacent over hypotenuse. That's the ratio. The cosine of 35 degrees, the adjacent we labeled as 4, and we're trying to find my hypotenuse, which the diagram labeled it as A. Put it over 1, and we do my cross multiplying. So this time, A would equal 4 multiplied by 1 divided by the cos of 35 degrees. So I can look at my calculator. 4 multiplied by 1 is still 4, divided by the cosine of 35 degrees, and we get, we'll round it to 1 decimal. We'll say that this wire is 4.9 meters long. So wire A is 4.9 meters. And now all we have to do is go and find that other wire. So again, I can erase this, and we'll say I'm going to look in this triangle with the 90 degrees, with this angle being 45. Now I want to find the length of this wire. So again, I could pull this triangle out, say here we go. This is 4 meters, that's my 90, this is 45, and I'm trying to find, and my diagram labels it B. So, reference angle, the adjacent side, and I'm trying to find the hypotenuse because it's across from the right angle. So again, this would be cosine, but now cosine of 45 degrees because it's a different angle. So this is adjacent over hypotenuse. The cosine of 45 degrees. Oops, that's a 5. Let me clean that up. The cosine of 45 degrees. The adjacent is 4. The hypotenuse is B. Put it over 1. We've had a lot of practice cross multiplying by this point. B is 4 times 1 divided by the cos of 45 degrees. So if I crunch this number out, we got 4 times 1, which is 4, divided by the cos of 45 degrees. And to 1 decimal place, that other guy wire is longer, and it's 5.7 meters long. So we found a lot of stuff in this question. We found the length of each wire, and we found how far the wires are apart on the actual flagpole, how they're attached. So what you need to do, and one of my biggest suggestions here is if you're really stumped, see if they're sharing a side and if that would help us actually find it, see where the right triangles are sharing a side. If not, it's really, really useful to go through and rip out these little pieces. So we're just looking at simple questions. We're not looking at this big complex diagram. rip out the diagrams, write them again, and then we're right back to where we started trig, just looking at one diagram and finding the information we need.